In this section, we are going to start tackling IS to IS, or intermediate system to intermediate system. We're going to start off with an IS-IS overview just to get your feet wet with IS-IS. I presume that you don't know IS-IS that well, so we're going to be taking you from pretty much the ground level all the way through to the penthouse suite with IS-IS and tackling a lot of the different aspects of IS-IS to really get a full picture of what the protocol can do. We'll take a look at levels and roles, how the levels come into play, the level 1 versus level 2, and then we'll take a look at the different roles that the different routers can handle, like the backbone router, the area border router, and then the stub router. It's not actually a true quote-unquote stub, but it acts like that in some regards. We'll then take a look at IS-IS addressing. IS-IS addressing is a little unique compared to what you may be familiar with when it comes to things like OSPF or EIGRP, where everything just looks like a regular IP address that you are likely very familiar with at this point. Where IS-IS is an OSI protocol, so it doesn't use IP standardization. It uses the OSI addressing standard, so it uses what they call a net address to identify itself. And we'll take a deep look as to what that actually means and how that actually works. Then we'll take a look at IS-IS adjacencies. We'll talk about how the adjacencies are formed, what needs to be in place in order for the adjacencies to happen. You'll find that IS-IS is a less complicated protocol overall than OSPF. It's more scalable and it's easier to work with. OSPF is a little more complicated, a little bit more over the top. So if you're good with OSPF, IS-IS is not that much more difficult to learn. We'll then take a look at configuring IS-IS in a multi-area implementation. We're actually going to start off with a single area. I'm sorry, well, we're going to have multiple areas, but one main level adjacency. So we're going to have level 1, level 2 as our default, and then as we scale IS-IS to do what we needed to do and check out some of the different geek tweaks and nerd knobs that are inside of IS-IS, you'll see what I mean by its scalability. Well, let's take a look at the designated IS, or the OSPF DR equivalency. This is going to act exactly like the OSPF DR does, where it's going to take in updates, and then it's going to kick those updates out to the appropriate routers so that you know what's going on in the network. We'll then take a look at IS-IS network types. Network types there's only 2 of them, point-to-point and broadcast, and you'll see what it looks like to run both of them and the different techniques for each one. There are a couple of caveats with each one, and we'll go into detail as to what they are and how they work. We'll then take a look at the IS-IS database. Not as complicated as OSPF, again. It's one of those things where, and you'll see pretty much every bullet point that we look through here is going to be easier than OSPF. The database is actually really easy to read, and it's just a little, the look and feel of it is just different. It's less complicated, it's less convoluted, and it's a little more straightforward, but the way you view it, some of the different outputs and stuff like that are different than what you might be used to. So we'll take the time to actually look through that and break down what you're looking at to identify what this is versus what that is and stuff like that. Then we'll take a look at the timers. Again, not a lot to work with here in IS-IS, but we'll take a look at that and exactly how you would manipulate IS-IS from the perspective of hellos and LSA pacing timers and things like that. We'll take a look at types and circuits. Now, the type will affect the circuit, but the circuit will not affect the type. And you'll understand that when we get into it. This is more of an the second slide here that we're going through is more or less optimizations. Once you've got IS-IS operational, what are some of the things you can do with IS-IS? So once we get the core built, building going through and setting up the optimizations, that will be very, very simple, very, very simple to do, and nothing very complicated. Then we'll take a look at path selection. How do you manipulate IS-IS, which is only one way to do it, and that's with the metric command at the interface level, and that's going to affect how you get routed through the network. Now, I don't remember if I specifically stated it at this point in OSPF, but when it comes to path selection, OSPF and IS-IS are the 2 routing protocols you are more than likely going to see in the service provider network. And the reason for that is because of the fact of IS-IS and OSPF allow the extension capability of using MPLS traffic engineering. So you can actually use IS-IS and OSPF to get reachability in the internal SP core from PE to PE, and then totally not even rely on the IS-IS metric in order to get from point A to point B. You'll see this when we actually get into the details, but you can use MPLS traffic engineering to get traffic from where you want it to go, anywhere in the network you need it to go, as long as you specifically state how you want it to be forwarded. Now we'll take a look at IS-IS summarization. Not very much to go on here. There's only a couple of things you can work with IS-IS on this, and we'll see exactly how that comes into play, where you can summarize the traffic patterns. You'll find out that when you're dealing with IS-IS, that depending on the level, adjacency, and the IS type, will dictate how the routing protocol, or I'm sorry, the routing tables are built, and how that could adversely affect the network. So there's going to be summarization out of the gate, when you don't even have to type a summary command or initiate summarization. There's going to be certain areas of the network, summarization will be in effect by default, especially when you go from a level 2 domain to a level 1 domain. And then you'll have a default route that'll be propagated depending on the situation. And then you may have to do a little bit of route leaking in order to get routes into the level 1 domain in order to provide reachability between two different endpoints. So I'll take a look at exactly how that comes into play and why that would be necessary in certain designs. We'll then take a look at authentication and high availability. Now, as an overview of IS-IS, IS-IS stands for intermediate system to intermediate system, or router to router communication. It is an IGP similar to OSPF and utilizes LSPs or link state PDUs rather than LSAs. It's got its own setup for that. That's just how IS-IS was built out. It is not proprietary, and any vendor can run this protocol. So I personally have seen this ran on both Cisco and on Juniper, and but that's the only two platforms I'm familiar with running it. I'm sure that there are others, but the only two that I know of for a fact that do run it is Cisco and Juniper. Now, they both use the Dijkstra shortest path first algorithm. So we'll be taking, it's the same logic that OSPF uses, because IS-IS utilizes the metric just like OSPF uses the cost in order to find the shortest path from between 2 points. And we'll see exactly how that comes into play. Really not a whole lot to work with. IS-IS was defined in ISO 10589 for CLNS, not the IP version. So that's going to be strictly the layer 2 setup here. RFC 1195 defines how to use IS-IS for routing TCP/IP. And if you didn't pick up on that, IS-IS isn't actually a routing protocol, and we'll talk about that here in just a moment. It utilizes SPF to calculate the shortest path, and it was integrated IS-IS was developed to support TCP/IP, and IS-IS is not a routing protocol. So it's actually part of the Connectionless Network Stack, or CLNS. It's actually part of the CLNP, Connectionless Network Protocol, and use the NET or the OSI addressing scheme, which, for those of you that happen to work on Novell and are familiar with IPX, SPX, they look like they are similar addressing structures and stuff like that. So that's how, for those of you that are familiar with that platform and Novell and NetWare and things like that, that addressing scheme will be pretty close to what we're going to be dealing with here. Now, the reason why you would use this, because it's used in the in the core of SP networks, and it provides the ability to build simple flat network designs that scale, and you can basically tweak it as you want to and as you need to. It supports both IPv4 and IPv6 routing, and does offer a 2-level hierarchy. So you have the level 2 backbone, and then you have your level 1 non-backbone areas. And you'll see exactly how this comes into play. One of the nice things about IS-IS is the backbone is not tied to the area. The backbone is tied to the level. So when we get into this, you'll see that level 2 is the backbone, and level 1 is basically the stub area, for lack of a better term. And that's basically how this one breaks down. Now, when it comes to IS-IS resources, there's a couple of books out there that I want to. There's a single book, IP Routing on iOS, XE, and XR. This will give you a good start and a really good foundation. It covers pretty much all the topics you need to worry about on the blueprint. And if you, the author did a really good job on this book. The benefit here for service provider is that it gives us the ability to see both iOS and iOS-XR syntax. So for every technology that the author covers, there is a XR and iOS syntax example. So as you're going through, it's very, very easy to learn how IS-IS DIS works, and you're able to see how to manipulate that on both iOS and iOS-XR. The other thing to definitely check out would be the Cisco documentation. So that is going to be going out, navigating to Cisco's website and downloading the syntax, or I'm sorry, the documentation, the configuration guide, command references for the appropriate iOS versions that you want to go learn, and then go out and test them. The documentation does do a really good job of breaking things down, and a lot of the information here in these slides it was found in the documentation, so it's freely available. I've basically compiled the documentation and I've put them into several slides to make the to make this video series basically a one-stop shop for IS-IS. So now we're going to go ahead and take a look at some IS and IS and OSPF similarities, because of course OSPF and IS-IS are very similar. So to help correlate IS-IS, I figured it'd be a good idea to throw some similarities out there. Both are designed as IGPs, so interior gateway protocols, so they route your internal network, and quite effectively, might I add. Both use areas, but in different ways. So areas in OSPF dictate the flooding domain of LSAs. In IS-IS, the area is just a dictation of the doesn't dictate the flooding. It doesn't dictate the flooding domain. It's just a way for you to help do topology summarization, just like OSPF does. Both maintain a link state database from which SPF is used to build the shortest path tree. That is going to be unique between the two of them, or similar between the two. Each one does it slightly different than the other one. One uses LSAs, the other one uses LSPs, but they both use a database to build the shortest path tree and to build the routing table. Both utilize hello packets. OSPF uses two different types of hellos, broadcast or multicast and unicast, and so does IS-IS. And just the simple fact that there are less network types in IS-IS than there is in OSPF, but it pretty much gets the same job done. Both utilize a two-level hierarchy. So that means that you can have your backbone and your non-backbone, or your leaf, spine, leaf, and everything works out quite well. Both have the ability to provide address summarization between areas. So you can summarize in OSPF easily, and you can do the same thing with IS-IS at different parts of the network, and you can do inter-area and external summarization as well. Both have are classless protocols, so they both advertise the subnet mask with the prefix, and you'll see that as we go through here more. You'll see how that comes into play. Unlike RIP or RIP version 1 is a class full protocol where it doesn't advertise the subnet mask with the updates. If you use the point-to-point type in OSPF, it doesn't advertise the subnet mask either. So we'll take a look to see if that is the case with IS-IS as well. Both select a designated router to represent the broadcast networks, so you know how a DR works. The designated intermediate system works exactly the same way. And both have authentication capabilities. So you can authenticate the hello and the LSP on IS-IS, and that's what we will take a look at a little bit down the road. Some of the differences. Yes, there are differences. Not many, but they are there. The first of which is the administrative distance is different between the two. IS-IS is less preferred than OSPF. Areas and interfaces. IS-IS does not put multiple interfaces of a router in different areas. Meaning, if you have two different interfaces on a OSPF router, both interfaces can be in different areas. In IS-IS, the entire chassis, or in our particular case, our virtual routers, CSR1000V and IOS-XR, they're both in, all interfaces are in a single area, and the link between them is the differentiation. So you could have one interface on a router being in area 0, another interface, the connected link that interface is attached to, the other end of that link, that router could be in area 10. So that's the only major difference between the two. Adjacencies, they have different rules. In IS-IS, PDUs reside directly behind the 802.3 header, and you will see that in the debug outputs, the Wireshark captures that we take a look at as we move forward through this particular section.